to this thing, you can
Sure.
Do any other start recording? Start.
No, I don't think we need
No.
to. No, don't need to do that.
Still not.
Well, it takes a few seconds after you go live. So let's see.
All right. Good evening, everyone, or good morning. I'm not sure where you are joining us from this evening, but I welcome you to the historic 60-inch telescope observatory here on Mount Wilson in Southern California. We were having a few technical glitches, so thank you for bearing with us for the first few minutes, but welcome. My name is Professor Jenny Krestov. I am one of the faculty members at Glendale Community College, just at the base of the mountain, and I am joined tonight by an amazing team of astronomers here on Mount Wilson. First, we have Dr. Jeff Rich, who is one of the astronomers at the Carnegie Observatories, and he is in charge of the outreach program. We also have with us Mr. Richard Bell, who is the telescope coordinator and is going to be in charge of our live feed from a smaller telescope, because at the moment where our location, the moon is quite low to the horizon and it's too low for the 60-inch telescope to point to it presently. We are also joined tonight by Mr. Tom Meneghini, who is the executive director here at Mount Wilson, and also our camera person is Dr. Chris Burns, who is also one of the astronomers at the Carnegie Observatories. So there he is. So
Bit dark in here.
there's a team of 5 of us here. To be honest, we weren't sure that this was going to happen when we were driving up from La Cañada at the base of the mountain. It was completely overcast, and higher in the mountain there we were driving through the clouds, but miraculously in the last hour and a half the clouds have dissipated and we are now looking at a clear sky. And to show you that, I'm going to go over to the tower cam view. So here at top Mount Wilson we do have a 150-foot solar telescope that has webcams that are facing in 4 different directions, and you can see on the bottom 2 of the image here, the bottom 2 images, they are looking at, they're looking south and southwest, or south on the left, west on the right, and that is, all of that glow there, that is the light pollution from the city of Los Angeles. The top right image is looking east, and you can see that bright object there toward the top of the image is the moon. So I'm going to take us back to the main telescope dome and then straight over to our view through a smaller telescope. And this is the moon, as you can see. On the bottom, obviously the bottom of the image we have the moon, and at the top you will notice that there is a little dot. That has an orangey tinge to it, kind of a golden orangey tinge. That is the planet Mars. So tonight you have tuned in to see the occultation of Mars. So first question you guys probably have is, what is an occultation? It is an astronomical term that describes when one object passes in front of another object and completely blocks our view of that second object. So tonight, the moon will pass in front of Mars, and it will completely block our view of Mars. And I'm just looking now, I don't know if it's my eyes or if you guys are seeing this too, but it looks to me like Mars is sneaking closer and closer and closer to the upper edge, or the upper limb as we call it, of the moon. Now, in reality, the moon and Mars are nowhere near each other. The distance, and I had to Google this because off the top of my head, this is not something that the average astronomer would know, but the distance today from the Earth to the moon is 384,400 kilometers, which in miles is 238,855 miles. Scientists do tend to use metric, which is why we use kilometers first. So we've got 384,400 kilometers to the moon. Mars is 82 million plus kilometers away. For those of you who need the exact number, we got 82,156,823 kilometers. I'm not exactly sure when that was taken. It may be 822 or 824 at this point, but 82 million kilometers versus 384,000 kilometers. Mars is, in fact, much bigger than the moon. It's approximately twice the diameter of the moon. But it is much, much, much farther away, which is why it looks so much smaller. So here we have the moon, and we have Mars, and we are in anticipation of the moon occulting Mars. Now, why are they moving with respect to each other? Well, the moon orbits the Earth, and together with the Earth, they orbit, the moon and the Earth orbit the sun. Mars also orbits the sun, but Mars is quite a lot farther from the sun than the Earth-Moon system is. So we have the moon orbiting the Earth. It does that every, well, as we see it, full moon to full moon, 29 and a half days. So it takes about a month for the moon to orbit the Earth, which is where we get our word month from, the monthly cycle. And it just so happens that tonight, the path that the moon is taking through the backdrop of stars happens to be in the neighborhood of Mars, and things are lining up perfectly, and we are going to see the moon pass in front of Mars. I actually looked this afternoon, I'm like, wow, that's great. How often does this happen? Well, it happens quite frequently, but it isn't always observable from the location where we are. So I think the last occultation you could see from Australia, I'm not sure, don't count on that information, but I was looking earlier, and there have been a number of occultations of Mars, and there will be more occultations of Mars, but they won't always be observable from Southern California, which is our location now. So we just thought this was exciting, and this team and myself have done some live streams in the past throughout the pandemic, and we thought it would be a nice evening to get together. But not gonna lie, it's a little chilly up here. It's a little colder than we were expecting, and a little colder than down the mountain. And my jaw is not actually functioning quite the way that I'm hoping it will, and I'm stumbling over words a little bit. So it is below 0 Celsius, it is below freezing. I think we're sitting at around 30, 31 degrees Fahrenheit. And if you're just joining us, you can see our view. This is a live view of both the moon and Mars, and we are waiting for it is going to block our view of Mars. And Richard is just zooming in here so we have a better view. He's moving the telescope so that the upper edge of the limb of the moon is more easily viewed. If you look closely at the top edge of the moon, you can actually see the heat haze, and that's not heat haze on the moon. The moon does not have an atmosphere. This will be the heat haze of the Earth. So during the day, the Earth receives a lot of energy from the sun. Visible light comes through the atmosphere, infrared light, some ultraviolet light, and that energy is absorbed by the Earth. At night, that Earth radiates the energy in the form of infrared radiation or heat. And this effect, this shimmering effect you see on the top edge of the moon, is caused by the shifting air mass, so the shifting layers of the atmosphere of the Earth as the heat kind of works its way up away from the Earth. So if you've ever looked over the top of a barbecue and you see some shimmering when the barbecue's turned on, or over the top of a road, especially a highway, if you're looking into the distance, you can see kind of a heat haze. This is what we're seeing here, but please don't think it's the moon. The moon has no atmosphere. We know this for sure. It is the Earth's atmosphere that causes this shimmering effect. It's the same shifting air masses of the Earth's atmosphere that causes our view of the stars to twinkle. So if you're in outer space, where the astronauts presently are on the International Space Station, they don't see stars twinkle. The light they see of the stars is rock solid. It is not twinkling at all. The twinkle that we get to see on Earth is purely a, I would say, Earth phenomenon, but to be honest, any planet that has an atmosphere, if you're standing on the surface of that planet, you would be able to see twinkling stars. So I'm just having a look at the chat here. So welcome. Welcome to Mount Wilson. We have people from South Carolina. We have Texas represented. Garfield campus, one of the satellite campuses of Glendale Community College. Welcome to Mount Wilson. We have another person from South Carolina. South Carolina is well represented. The Bay Area, and I'm not sure if we have more people up or down the chat because I don't have access to that, but welcome to Mount Wilson. It is almost time for the occultation. NASA did say that occultation would start out Connecticut. Awesome. We got more people. All right, so NASA did predict that NASA did predict that the occultation would begin right at 6:30. So we've got a minute to go, and we can see that this is the distance between Mars, which is that little orangey circle, and the top edge of the moon is decreasing. So NASA said 6:30. Maybe it's 6:30 in 30 seconds. I suppose we'll have to see.
Well, it all depends on our longitude and altitude and,
Yeah.
all that stuff.
All the fine details.
If anyone's got questions on the chat, feel free to just ask them. We'll try and keep an eye on it and answer them as they come out.
Welcome from Georgia, from Delaware. Rhodesia Island? I don't know, I'm thinking Rhode Island. But welcome, we're almost there for the occultation. It almost, I'm zooming in so much looking at the moon that to me it looks like the moon's dancing around a little bit. It almost looks alive and it's gonna like gobble up Mars. But here it comes.
All right, 6:30. That's when it's supposed to start. So I guess we got a few seconds.
I guess this is maximum zoom.
Wow. We can zoom more. Let's go all out.
Oh, we're going all out with zoom. So you can see that from our perspective, part of Mars is now being partially occulted by the moon. And by Mars,
It's Mars set.
it's Mars set over the lunar landscape. This is fantastic. And there it is.
All right. And now, it'll be another hour before it comes out the other side.
Yes, so you have to be patient. We can stare at the moon for an hour, but to be honest, we thought you'd get kind of bored with that. So we do have some other astronomical wonders to show you, and I'll bring you back to, oh, my fingers are frozen. My nose is all red because it's quite cold
Why
in
don't we
here.
do the big view of the telescope?
Yes.
'Cause it's
So we'll
curvy.
show you the facility that we are presently located in. This would include turning the lights on, I would imagine. Okay.
Lots of lights.
And then we'll go to a view that we have of, nope,
No, that's right. Go.
that one,
And then that.
and then number one. Hi. So this is a lit dome. We don't usually have the lights on to this extent unless we are kind of organizing things or moving the ladder. But this is the historic 60-inch telescope here at Mount Wilson. And if I remember correctly, it opened in 1901?
1908, this one.
1908. I was off by more than half a decade. Bad me. So 1908 is when this telescope had what we call first light. And it was, when it was built, it was the largest telescope in the world. And it was cutting edge technology. So I believe Chris is going to take you on a tour around the telescope and show you some aspects of it. So let's get to the zoom view.
I just wanted to go to this over slide.
We're only at the meridian. I think we're okay. All right, let me see. Hopefully this will work. All right, so I've got the steady cam. Are we on me?
We are. Is the Rode Wireless working, Jeff?
Can you hear me? Okay, I'll just start talking and assume that we actually are okay. Oh, and good, you've got the flashlight. Okay, so what you're looking at here is the backside of the telescope, and we are currently pointing at Jupiter. I don't think, I think you can just barely see it in my telephone view. It might not come through on YouTube, but that's what we're pointing at right now. And it's called the 60-inch telescope because the primary mirror, which is the focusing element of this telescope at the bottom, is 60 inches in diameter. And as we said, this came up and started functioning in 1908. And if we go underneath here, we can see the bottom of the mirror. And it should show up as green. There we go. And, so we can see little spots on the back from a little bit of condensation from earlier, perhaps. One of the things that we were a little bit worried about was that the humidity would be a little bit too high. I don't know if you can actually see my breath, it's steaming. But we have limits, and the reason for that is because we don't want the front side of this mirror to get condensation, because then it can leave little spots, just like that, on top of the reflecting medium, and that will degrade the image. So we were watching the humidity very closely, and it came below, or just about at 80%, and that's our limit. So lucky for us, we were able to open it up. Now, normally up here is where visitors to the observatory, if they were to, say, rent out this telescope for a half night, that's where the eyepiece would be. And we have this wonderful, large ladder that would allow you to get up there. But tonight, for your viewing pleasure, we have a CMOS camera. So this is an electric digital camera, and the nice thing about a CMOS is the readout is very fast, and so it's almost like a video camera. But we can also take long exposures if we happen to look at something that's a little more deep sky. All right, so since we're already pointed at Jupiter, maybe it'd be good to go and actually look at Jupiter. So we're going to turn the lights out, and later on we'll show you how the telescope moves when we go to another object.
All right, so we are back here. Let me see if I can get the view through the telescope. Now, we're looking at Jupiter right now.
Through the 60-inch.
So this is through the 60-inch. Wow, sweet. Okay, so we are looking at the largest planet in our solar system, which is the planet Jupiter. And it, you can see the stripes in its atmosphere, and it is in the center. So I'm just looking at, and I don't think I can do it with my mouse, but if you follow the line that is kind of etched out by the bands in the atmosphere of Jupiter, you see one moon to the left, and then there's another speck of light
Here's a quick way to do it.
over to the right. Oh, there you go, that's easy. And that's kind of blown out the exposure of Jupiter, but you can definitely see the moons. Now, do we have which moons they are? We do. So the one on the left It's the kind of lower one on the left-hand side of the screen. That is going to be the moon Io. The one on the, and so that's the one, no,
Other way around.
is the other way around. Okay, so the one on the top right, that's Io, which is the innermost Galilean moon of Jupiter. And the one toward the bottom on the left-hand side, that's Europa. And Europa is the moon that is of real interest to astronomers, because Europa, we believe there is a ocean of liquid water beneath the icy surface. So these are two of the Galilean moons that we can see. Jupiter does have 4 large moons that were first observed by Galileo back in 1609, and he didn't call them the Galilean moons. I think he called them Medici. Yeah, they were the Medici stars after his patron, the Medicis, the family in Italy. But now we know them as the Galilean moons. Interestingly enough, Jupiter has 4 very large moons. These are the Galilean moons. They are, 3 of those 4 are larger than the Earth's moon, so they're quite large. All of the other moons of Jupiter, and there are 78 moons of Jupiter, all of the other moons are much, much, much smaller, on the order of only hundreds of kilometers across, not thousands of kilometers across. So it's really quite interesting. Now, I am looking at a different view, which I think I can go to. Is this number 3 or number 1?
Did you want to do Sky
Nope.
Safari?
Yes, Sky Safari, there we go. So we have a laptop set up with an app called Sky Safari, which is one of those apps. Actually, I think it's an iPad, isn't it? It's one of those apps you can point it at the sky and kind of figure out what you're looking at. But it's great because we can zoom in and have a great view of Jupiter. So this is an app. This is not a real view of Jupiter, but these all are real photographs of the planet that were taken when spacecraft actually went to visit the planet. So there was the Galileo spacecraft, Juno is out there now, and I'm blanking on the one that was there for a long time. No, it was Galileo, wasn't it?
Galileo.
Yeah, so Galileo was a spacecraft in, a couple of decades ago now. But it was out there, it was circling Jupiter for many years, and it took some amazing photographs, and these are those photographs that you're seeing now. So I can zoom in a little more, and you can actually see that there is structure in the atmosphere. Oh, it's so pretty. Oh, structure in the atmosphere of the planet. So Jupiter itself is not gas all the way down to the core, so to speak. Believe it or not, even though it's known as a gas giant, scientists believe that the bulk of the mass and the bulk of the volume of Jupiter is actually liquid. It's liquid metallic hydrogen. Hydrogen on Earth is generally considered a gas. Hydrogen in Jupiter is going to be this liquid metallic form. So I'm wondering, Chris, is this one of the moons here?
I don't think the moons are. Let's zoom out and you'll see if all 4 moons are. Yeah.
Yeah, okay, so it's not one of the moons, it's just a feature. So I was looking at this feature just top right. It would be a storm. So I can't, I'm putting my finger, ooh, nope, that's not right. So on the top right of your screen here, that's a, it's like a cyclone. It's like a hurricane except without the water, the rain. But there are many storms in the atmosphere of Jupiter, because believe it or not, the winds go in different directions. So the wind in the upper dark band can be going in one direction, and then that central kind of pale white-yellow band, the winds will be going in the opposite direction, and then the dark band, like so if the dark band at the top, the winds go to the left, then in the central white band, the winds go to the right, and then they go, so there's turbulence anywhere between where those two bands kind of meet up. It's an extraordinarily dynamic place, is Jupiter, and we are having a look at it with the 60-inch telescope.
There was a comment, I think, a little further out that said even nicer, that Jupiter was even nicer than Mars. And if we didn't, maybe we didn't explain, but the first view you saw of Mars going behind the moon, we did with Richard's refracting telescope, which is also up here on Mount Wilson. But in the 60-inch dome, you may have seen when you saw the wide view, we're looking through a shutter in the dome, and it limits how far down we can see. And other mechanical limitations of the telescope don't let us go all the way over to where Mars was going behind the moon at the time. So in an hour, we will be able to point the 60-inch telescope at the moon and Mars and hopefully see Mars come back out, and you'll hopefully see a better view of it because we'll be looking through a bigger telescope, and the bigger telescope gives us better resolution, a sharper image than you can get with a smaller telescope on good nights if the conditions are good.
5-inch refractor, 60 inch.
Yeah, so Richard's refractor is 5 inches in diameter, and the 60 inches in diameter. And that directly tells you the difference in resolution if the skies are very, very steady. If the skies are kind of not very good, well, then it maybe doesn't really matter what you look at it with. You won't see great details, but it's looking pretty good tonight. I'm actually really quite pleased with how well the seeing is, given that the clouds were nearly on top of us.
Let's go have a look at those clouds. So we're back to the tower cam, and the tower cam does refresh every 10 seconds, I think, or so.
I don't know, actually. A minute?
Or maybe every minute. But these are looking in different directions. Top left, we have looking north. Top right, we're looking east, and you can see the moon in that image. Bottom left, we are looking south. And there's another solar telescope. You can see that weird tower with the bulbous top. And then bottom right, you can see a lot of the radio and telecommunication towers that are also atop Mount Wilson. And interference from those telecommunication towers is often why cell phones don't work up here on the mountain. So we are going to...
We're going to go to Saturn, so why don't you go to the view so they can see the telescope moving?
That one? No, this one. That one. It has been a while since I've been at these controls, over a year and a half, so I'm a little rusty on the controls. But, welcome.
Now you can see the dome moving.
So obviously we want to keep our telescopes well protected from bad weather. That's what a telescope dome does, or an observatory dome. I suppose you can open them up entirely. A dome open up entirely if you're observing. This dome just has kind of a strip of the ceiling that has been rolled up and taken out of the way, and then you can turn it on a bunch of rollers to point in any direction, or rather have that opening face any direction. And how we have the opening depends on where we want to point the telescope, which depends on where the object of interest is in our sky from our perspective.
And what you just said, the more modern observatories with the big telescopes and the big domes, the current wisdom is that you do in fact want to open up the dome a lot. So they have
Completely.
these louvers on the side, and they open them up and allows the air to flow more smoothly across the telescope. So right here, if the wind's blowing, the wind will come into the shutter, and then it will kind of turbulently kind of tumble around, and that can, decrease your sky conditions. I think we're almost there, so I'm going to turn the lights out. And
Okay.
see how fast we can get this thing centered.
All right, so this is exciting. We're going to see Saturn. So if I get, do you have a view of Saturn yet?
Give him a chance.
Okay, we need to be patient.
Oh, I should also say one major improvement that we've made since our last. One of the major improvements we made since our last webcasts is there's an electric focuser where the camera is up by the eyepiece that we can control from the same the same computer that we're using to look at the image. So we don't have to have somebody up there turning the knob ever so slightly, and then we can tell them, oh, it's better, oh, it's worse. Or at one point we even had a third monitor, but it was far away and it was hard to see.
You can go and show them the controls while we wait.
We could go. Which
Oh,
controls?
have we got Saturn? Not yet? Well, just how you move the telescope. Did you go over there earlier?
Well, we can do that when we go to something else.
Ah, this is true.
Then we'll see if we can. Saturn is lower. Oh yes, we're now in. Actually, let's go back to the ATEM. Yeah, do the ATEM thing. Can you tell that? Well, maybe not.
Now it's dark.
No, it's too dark. Okay, never mind. Anyway, we are getting low, and when we get low, we got to be really careful about how we move the telescope because it's now in a position where the rails on either side of what we call the Newtonian platform.
Just looking
We all
at
get
them.
nervous when that happens, but he's just centering it. We're good.
I don't know if we can move this around to show them.
Oh yeah, I
I
can do
don't
it.
know. You're gonna have to do it.
It's got the stabilizer, so it's.
Does that seem better?
Yeah, a little better.
A little better.
Where I don't know if you can see the scaffolding kind of coming from the center left up toward the middle, and then that white railing, just a couple of rectangles. It's looking, they're very close to each other, and we got to be very careful because the telescope will track. Hang on, the telescope will track whatever object you're looking at, and then you have to make sure that you move the dome to not interfere with how the telescope is moving.
You just see someone says they're watching from the comfort of their lazy boy. I'm very happy for you.
Yeah, it's cold up here. It's about -1 degrees Celsius, about 30 degrees Fahrenheit. My nose is nice and red.
Would you make your Mount Wilson look?
We have Saturn.
We have Saturn.
A hot chocolate would be lovely. Thank you. Okay, so we have Saturn. Let's go and have a look at Saturn. It looks quite green.
Yes, right now it is, until we get it over in the center.
Okay.
Yeah, so if you may notice, aside from the view of Saturn, there are all these little bells and whistles on the side, these little buttons and sliders and things. And the sensor inside the CMOS has color, basically a color grid. So each pixel has red, green, and blue filters in front of it. But how you mix those together to make color is up to you. You can change that. So there's usually a natural way to do it, but you can tweak it. And if you've ever seen these NASA images, especially of the new James Webb Space Telescope stuff, all those colors that you're seeing are completely artificial because James Webb usually observes in the near infrared and the far infrared, or mid-infrared. And so our eyes don't know how to interpret that kind of energy of light. And so what they do is they artificially assign a color that we can see to each of those infrared colors. And so as Richard moves Mars into view and we play with the focus a little bit and the exposure and the gain and turn up the lights and get a better view, then the other thing we can do is we can start playing around a little bit with the what we call color balance. How much red you want to see versus how much blue versus how much green. And that lets us, give it a bit more of a natural color, kind of like what you would be seeing if you were here at the top of that ladder looking with your eyeball through an eyepiece. This is kind of what we're trying to do, is give you that kind of experience from the comfort of your home. The other thing is, of course, tonight we have a full moon. Mars is at opposition. I don't know if we mentioned that, or very close to being at opposition. And that just means that Mars is on the opposite side of the sky from the sun. And since the moon is passing in front of it, that means the moon is also on the opposite side of the sky from the sun, and therefore it's a full moon. And because it's a full moon, we're going to get more sky background than we would on a darker night. And of course, we've got Los Angeles, which has all its light pollution, and that never helps. In fact, if we go back to here.
We're just looking through a lot of air.
And the other thing is, if you saw how pitched over the telescope is, we're also looking through a lot of atmosphere, and so that's also going to affect the image quality. But you can see when you look in the south part of the image, which is to the lower left, you can just see how bright Los Angeles is. So we're going to try and do the zooming and the...
Now it just brings it to center.
Just bring it to center. There we go. Now, I think we can see pretty clearly the Cassini division. So if you look at the ring going around Saturn, it's not, a complete solid. Hopefully, folks know that the ring of Saturn is a bunch of ice particles and dust and boulders and stuff like that. But thanks to the orbital mechanics of moons and other things like that, there's actually quite a bit of structure to that ring. And if you've seen the images that came back from Cassini, there's just rings and sub-rings and all kinds of stuff. But the one we can normally see pretty clearly here at Mount Wilson with the 60-inch and the 100-inch is the Cassini division, which is sort of the most prominent gap in that ring. I think you can probably also see that the planet itself is casting a shadow on the ring. So the ring on the right appears to go right behind the planet, but on the left, the ring kind of stops right before it gets to the limb of the planet. And that's just because the angles are such that the planet is casting a shadow on the ring. We checked for any questions?
I've answered a couple in the chat. But
Oh, you
some
did?
of the
Okay.
other ones, yeah.
All right, that's fine.
Somebody asked about the effect that the alignment of Mars and Moon and Earth has on Earth, and I
I don't know,
mentioned
did
that.
you feel anything?
No, well, I mentioned that Earth, Sun, and Moon alignment really does affect the tides. And
Yes,
put
yes,
a
it
link in the
does.
chat, but Mars
Yep.
is far enough away; it really doesn't.
I'd like to think that it affected the clouds, and it took
Yeah.
the clouds away from us,
I'll take
and we were able to see this. That's actually not going to be true, but
Someone actually asked a really good question, which is why is it not an eclipse? Is an eclipse different than an occultation, and what's the difference? And I found a nice NASA website that says an eclipse is just an occultation, and an occultation is the fancy word we use for there you go. Anything that blocks a bigger thing that blocks a smaller thing.
Yeah, okay. Do we have Titan? I guess it's kind of far away. Or any other moons. Did you try putting up the exposure to see if we can see any moons?
We should be able to. That's the current.
Ooh, we could, yeah, why don't you go to Sky Safari and,
There they are.
there we go.
Cool.
So 1, 2, 3, 4, 5, I think.
3, there's a one right here.
Looks like, oh, wait, flipped. So it's reversed and upside down. So we'll see what Sky Safari
Yeah, let's see
says.
what Sky Safari is.
Because like Dione is the one in the middle closest to the disk. Or Dione.
Okay, so we've got
So it needs to be,
Mimas. Is that the one? Mimas and Enceladus on the left, maybe?
So that's the side where the,
the two that are together. Yeah.
Oh wait,
Teth-
no. So that's flipped.
Tethys and
I think
Enceladus.
So
I think it's
Mimas
flipped
is too
vertically
small.
and horizontally.
oh, that makes it lovely. That's gonna be
okay,
be
so
hard.
Titan is over there.
Well, Titan's out. I think Titan's out. Oh, there it is.
Yeah.
Is that it? Okay. All right. So Richard is now pointing his
That's
mouse
Titan, right.
at Saturn's largest moon, Titan.
And Rhea will be the next one in.
Next one in is Rhea, whatever.
Mm.
What's the one above the planet?
Hyperion?
I think it's Dione.
Is it?
Yeah, it's the one that's closer
Yeah, I think
because
that's
we're
right.
flipped vertically.
Yeah.
Okay.
Yep.
Yeah.
And that would be Enceladus
Mhm.
and Tethys.
Hyperion is floating around somewhere out there down
Minus is
here.
usually right against the ring, and it's so small it never shows up.
Yeah, I'm not seeing it. Well, there we go. Lots of moons. And interestingly, it's always fun to watch Saturn's moons because they're not all in this wonderful lineup like Jupiter's moons are. And that's just our relative view of the angle of the system. Or actually, Jenny, do you know, are Saturn's moons just in somewhat more inclined orbits or relative to Jupiter's?
I think they are. Certainly the Galilean moons are all coplanar with the equator of
Yeah.
Jupiter, but I think the moons of Saturn are smaller in mass and more easily gravitationally disturbed.
Right.
So they're less likely to be coplanar with the rings and the equator of the planet.
So can we look up what the distance is?
The distance to Jupiter?
Yeah, just hit the little eye.
I,
Little eye there.
okay, my hand.
Actually, you know what? Let me. I can show that what you're
Oh,
doing.
no, that's Mimas.
So here, Jenny's. We're using Sky Safari again, and it gives us some nice little details on. And so I can't read it from here because it's too small.
It is,
It's almost. Oh, there we go. It's 10.2 astronomical units. That's a fancy unit stick that we use in astronomy for solar system bodies. 1 astronomical unit is the average distance of the Earth from the sun, so that's a good yardstick to use. So essentially, Saturn is currently 10 of those away from us.
So at 1.5 billion kilometers.
Yeah.
Okay, there we go,
So
1.5 billion
if we go back
kilometers.
to the beginning, the moon is presently 384,000 kilometers from us.
Mm-hmm.
And Mars is 82 million kilometers from us. And Saturn is 1,530 million kilometers from us, or 1.5 billion kilometers. So yeah, we're looking at things really far away.
Or 85, is that 85?
Yep.
Light minutes. So what you're seeing here is the way Saturn appeared 85 minutes ago. So we never see the universe as it is right now, even thanks to YouTube. I mean, all that aside, there is an ultimate speed limit in the universe, and that's the speed of light. So we're always seeing things in the past, and that actually can be quite handy for astronomers because we can see the history of the universe just by looking at things farther and farther and farther away. But it's a real pain for anyone who wants to send a spacecraft out to these distant planets or asteroids because you may see something going wrong and you send a signal for it to correct its course, but well, if it's at Saturn, it's going to take 85 minutes for it to get there. And then you got to wait 85 minutes to see, well, did it work? So it's very, very hard. Space is hard. Space travel is very hard, especially robotically. And so it always amazes me, the folks at NASA and JPL, how they can make these rovers and space probes very self-reliant. They have onboard smarts that can make them, react to things that we simply cannot, simply because we can't send a signal fast enough.
I double-checked. Saturn is winning the moon competition right now.
Saturn now currently has more moons discovered than Jupiter. Now, do we believe that that's because they have a different distribution of sizes, or because Jupiter's closer, so I'd expect that you'd be able to see them more easily.
I mean, some of these numbers might change as we discover more of one or the other, because I know that in the past Jupiter had more moons than Saturn, so part of this is simply just observations.
Right.
But
Okay,
That's a good
it
question.
is 7 o'clock. Which means we have another half an hour before Mars nominally comes out from behind the moon. So we could move on to something else. Okay, we are going to try going to something called the Blue Snowball. This is a planetary nebula. We're going to put the lights on and switch to the telescope view so you can see it move to its new location.
should we show them an eyepiece so they can see how big they are?
Oh, and we can show you an eyepiece and see how big they are. Let's do that.
All right. Gentlemen. I will come back and sit in the driver's seat, so to speak. We are going to keep our eyes on Saturn until such time as the lights come up.
Are we going?
We're looking, we're
Oh,
playing.
you're looking. Okay.
Okay.
We're just making sure we can see it.
Mark 23 in Zenith. Byron? That's all I was wondering.
So I'm just seeing someone posting in the chat that if anyone ever comes to LA, we should take a day trip up to Mount Wilson, and I heartily agree. Mount Wilson is the tallest mountain around. It is in the Angeles National Forest to the north of LA County. It is beautiful up here. Even after the Bobcat fire, the wildfire a couple of years ago, it's started to become green again. It's quiet on the mountain. The skies are stunning. You can see the Milky Way from here. It's
a great place to visit.
It is a lovely place.
And if you do come to visit, come on weekends during the spring, summer, and fall. They give tours on Saturdays and Sundays most of the time when the when the observatory is accessible. And the tours, I think, start something like at 1 o'clock and maybe 3 o'clock. Anyway,
Yeah.
check the website. There is a website, mtwilson.edu. It has all the details about visiting the observatory. If you are inspired to rent out the telescope with a bunch of friends, all the details are there as well. So you can, come up here on a good night. The telescope is yours if you pay for it for a half night, and you can look at it whatever you like.
Yeah. And
Oh, here we go. We're moving.
Oh, we're moving. Okay.
I get the big lights?
Turn the lights on.
Just so we can see what's going on.
Can you see the telescope move?
All right, and Jeff is demonstrating one of our eyepieces.
Do you want to grab that?
Yeah, I'll grab this and
Yeah.
turn it around.
Since you were talking about, oops,
Oh, hang on. Which way?
Okay, there we go.
am I looking at me?
Yes.
I'm looking at you now.
Since you were talking about coming to look through the telescope, which is a thing that you can do here, tonight we're using a camera that Chris already showed you, but if you come on a night when you can look with your eyes, you can look through an eyepiece just like this one. If you've ever looked through a telescope before, usually eyepieces are standard 1.25" diameter, so something like that. And like looking through a little thing like this. On this telescope, you get to climb up a nice big ladder. You might even get to stand on the telescope and look through a giant eyepiece at whatever the telescope is seeing. Now, cameras are a lot better than our eyes at seeing things, so you're going to get some spectacular images from the cameras tonight. But there's nothing like looking through a big eyepiece, even a small eyepiece.
Take the cap off.
Take the cap off.
Take the cap off, just so you can see it.
Oh, otherwise,
Oh, is
It's
it?
pretty impressive.
There we go. I
Like
think if you look through the other end,
can we do this?
does it show up? Can you see his face?
I can push it away from your face a little bit and then go up.
There you go.
Oh yeah, your whole head's upside down, and it's teeny tiny.
Excellent.
Yeah. So in
Lovely.
any telescope, you have to have two elements. You have the primary focusing element, which in this case is our mirror, and then you have to put a lens at the other end so that your eye can see what the telescope sees. Should we turn the lights out? Okay, lights are going out.
We're back here.
Back there.
Do we have the blue snowball, or we're still waiting
we're,
for it?
we're getting there. So the process, whenever we change to a new object, is that we have to rotate the dome. That's what you hear right now, which has been compared to a dying coyote. If you're up here at night and you hear something like this is the dome rotating. And we're just going to turn that until it's facing the right direction. And then Tom, who is the telescope operator tonight, he looks up the coordinates in a catalog. We have this wonderful list of objects called the Nicholson list, named after Seth. Wait, I always get it backwards. Is it Seth Nicholson who made the list?
I think it's Don Nichols.
Don. Oh, yeah, so his son Don was the one who put this together, and it's a list of really great objects to look at through these telescopes. You probably have noticed that when we were looking at Saturn, we were really zoomed in, and that's because the way these telescopes, the optics are put together, they have a very narrow field of view compared to, say, a backyard telescope that you might use. And so we tend to look at things that are small, compact, and bright. So planetary nebulas, planets, globular clusters, double stars, things like that. Some compact galaxies also look pretty good. And I think the dome is just going over us
It's
now.
right over our head. I don't know if you can see that right up there.
Let's try this.
Oh, yeah.
This one.
So I'm hearing all this stuff right over our head, but we now
Yeah.
have a brand new kind of ceiling above our head, which
Yeah.
is part of the shutter.
There it goes. So that's we call that the Newtonian platform. And one of the interesting things about this telescope, it was I think the first reflecting telescope that you could change the configuration relatively easily. So the very top of the telescope, we call it a cage, that comes off and you can change how the telescope works. Right now, the eyepiece is sort of near toward the bottom of the telescope. There's another configuration where you'd be at the top, and that's called the Newtonian focus. Gives you a wider field of view. And in that case, you would be on that platform that just passed over us, and that platform goes up and down along the inside of the dome so that you can get up to where you need to be.
That's for the people who are not afraid of heights.
Yeah.
That would not be
I've
my
actually
choice.
never been on it when it's been up there. So we're still just waiting for getting centered. You're on it?
They're impressed. Someone's impressed that the images of the planets and the moons are clearer than the images they are getting of us. So one of the issues with the image on a webcam is that regular cameras require a lot of light to make good images, and we are in a very low light situation in our little
Yeah, and so right now we're
in our little
centering,
dark
it
place.
should be centered on this planetary nebula, but because it's not as bright as a planet, it's called a planetary nebula, but it actually has nothing to do with planets.
Planetary nebula. Okay, this is great. So, a planetary. Ooh, we're gonna have a look at it.
Okay, there we
It's
go.
coming in from the right-hand side. This is a beautiful view this evening.
Okay, the
it
seeing's
looks like
really
a
good.
jellyfish.
The seeing is really good tonight.
It's not a jellyfish. So this is a regular star, a medium mass star, much like our sun, that has used up all of its nuclear fuel. At the end of its stellar lifetime, I mean, please don't think that stars are alive, they are not. But at the end of, when the star has exhausted its nuclear fuel, the core collapses, and you can see that collapsed core at the very center of this nebula. It is a white dwarf. So this is the collapsed core. It's made of carbon and oxygen, and surrounding it is what had been kind of the bulk of the star, the atmosphere of the star, and it is being expelled. Now, those gases that are being expelled are actually energized by ultraviolet light from that white dwarf at the center, and that ultraviolet light is causing those gases to glow. In the same way, if you put neon gas into a glass tube and energize the neon gas, you get a bright orange color. These are your neon tubes that say open for shop windows. These gases are glowing. Now we're looking at a bit green here, but is
That's
it
the right
actually
color.
green? Yeah,
Yes,
it
it
is.
is. And this is one thing I like to talk to folks about when they see this with their eyes. What you're looking at is actually called forbidden light. Why is it forbidden, they ask me. That sounds interesting. It turns out that when physicists were experimenting with different elements in the lab, and this was happening here in Pasadena. In fact, we like to say that Mount Wilson is the first place that astrophysics was born, because while the astronomers were making observations, the physicists were down making experiments, and they were matching things up. And so in the laboratory, you can take different elements like copper, oxygen, and things like that, and you can heat it up, and you can see what kind of colors these elements produce when they are basically excited, when the atoms are excited. However, this color, this very specific color you're seeing here, this sort of bluey green aquamarine, had never been seen before. And so they thought, we've discovered a new element, and they called it nebulum because it came from a nebula. But it turns out what you're seeing is just plain old oxygen. But oxygen is an atom, and there are electrons in that atom, and the electrons dance around between these different levels we call orbitals. And some of those transitions are allowed by the laws of physics, and some of them are not. And it turns out this particular green light that you're seeing is produced by a transition of the electron that's supposed to not happen. For reasons I can't remember. It probably
Dun,
has
dun,
something
dun.
to do,
It's
sorry?
collisionally de-excited.
Yeah.
typically.
So anyway, in quantum mechanics, nothing's really forbidden, just very, very, very unlikely. And so if you let this electron just sit around for a while, maybe 10 years, 100 years or something like that, it will spontaneously make this transition even though it's not supposed to. But in the laboratory, these atoms are colliding into each other all over the place because the densities are so high and the temperatures are so high relative to space. It never gets a chance to do this. It gets knocked around to some other transition and just never see it. But in the deeps of space, you know, densities are like on the order of a particle per cubic centimeter or something like that. So these electrons and these atoms have a chance to just sort of chill out, wait, and then bang, they make that transition, they make that color, and because there's just so many of them in that nebula, we get to see this really nice green picture of forbidden light.
And I do want to show you the picture that we have from the app that we're using, which is over here. So you can see our telescopic view and the one that we have, kind of the best image humans have ever produced of this same object. They're pretty comparable. We have beautiful observations tonight, and here we were thinking that tonight was going to be a bust because it was so cloudy on the way up. But this is an object known as the Blue Snowball Nebula. I noticed in the chat someone said, oh my gosh, new word for most of us, and that's occultation. If you don't know what a nebula is, it is simply, I believe, the Latin word for cloud. So this is a cloud of gas and dust in outer space. I first learned the word when I was quite young, when my older brother called me a nebula head, and I thought it was, he did. I thought he was being nice and complimentary, and then I learned that he was basically calling me vacuum head, because the density of matter in these nebula are quite low, and these nebulae are quite low. Mars should come back into view. I'm just responding to something in the chat. Mars should come back into view at 7:30, and we are, I think, looking at it through we have eyes on it through the 5-inch refractor. Nope, we don't.
Well, it's still behind the moon.
It's still behind the moon. So what time do we have? I don't even have a clock here. 7:12.
Yeah, so
So we
we got like
have,
15 minutes.
in 15 minutes, we'll go back to the moon to be able to see it come out, and we're gonna go back to the moon using this 60-inch telescope, which I have to be honest, I'm super excited
We're gonna
about.
try and do. In the meantime, we actually have something else to show.
Oh.
Richard, if you want to bring over the picture of your oop, it went away.
Yeah, it went away. Well, that's,
I can tell you another fact about the blue snowball, since
then
we're
we can
talking
bring
about
this one over.
distances.
Oh, yes.
Come around here.
Yes, please
It-
do.
I'm cheating because Sky Safari is right here. It's about 1 light year across. So the diameter of the thing you're looking at here from side to side, that fuzzy stuff, it takes light about 1 year just to travel across that thing. And the distances are tough to measure. It looks like Sky Safari says that the most recent measured distance is 5,000 light years away. So we've moved to units that astronomers commonly use, like light years, because to convert that into kilometers or miles would be an incredibly large number with lots and lots of zeros behind it. So we tend to use,
Wait,
I was reading off the text. There's
Okay.
some flavor text below that mentions that it's a more recent measurement of about 5,000 light years on the left side.
okay, yeah.
Which is interesting. It's not really easy to measure distances to almost anything in space outside the solar system. So the fact that we're uncertain about the distance to this thing by a factor of 2,
Yeah,
yeah, 3.6, it could be 3,600 light years, or it could be 5,000 light years. So either way, it's quite far. A light year is how many kilometers?
I don't know, I think it's 208,000 AU. And an AU is 149 million kilometers. So it's 208,000 times 149 million, and I'm gonna be honest and say I can't do that in my head.
I just remember
ask Siri.
there's pi times 10 to the 7 seconds in a year. And 300,000 kilometers per second. I don't know, so it
Yeah,
goes together.
so someone out
It's a
there
big
has a
number.
calculator and can do it for us. or just Google, how many kilometers away the blue snowball is.
10 to the, pi times 10 to the 7
But
times 10 to the 5,
this
so
is a
10 to
beautiful,
15
beautiful view.
-ish.
By the way, if you're wondering what those 3 dots are in our view, as well as the 3 dots in the Sky Safari app information view, those are stars. And I don't know if they're background stars that are farther from us than the nebula, or if they are foreground stars. Again, as Jeff was saying, determining distance to objects in outer space is very difficult. Just by looking at them, you can't tell if it is a bright star that's far away or if it is a more dim star that is close. So, yeah, we have the Blue Snowball Nebula, which is just stunning. Like, wow, that's the best I've ever seen it.
That is the best I've ever seen it. So, something else we can show you.
If I can bring it back. There.
Okay, so Richard's going to bring over a picture of his refractor. It's a live view. He's got a web camera in the roll-off shed.
It doesn't want to go.
Doesn't want to go.
It doesn't want to
Oh,
come.
yeah, I know why. Never mind, I'm sorry.
Okay.
Okay.
Whole thing.
All right. So, do you want to describe it?
It's on. Yeah, the mounts are fully remote controlled, so I actually can run this from anywhere in the world, as long as I have a computer. And it's got a Paramount MX mount, and it's got a TNB 130 millimeter refractor on it, and it has an 80 millimeter one above it in case I want something with even wider field of view. And that whole building that you're seeing, this door here in the background lowers down, and then the entire building rolls back, exposing it to the air, which is freezing right now. So you see chairs there, but that was rather optimistic for the summertime. We definitely don't go out there in the wintertime. And currently, this particular refractor, since we're waiting for the Mars to come out, is on M15. If you want to talk about that, it's M15, the globular cluster.
Yep. Okay, so we're moving our way out. Let's bring that up. Forget how far away it is. This is an example of what's called a globular cluster. And this is a collection of probably something on the order of 500,000 stars, all crammed together. They all formed out of, we think, the same large gas cloud. And so they're all in the same physical location in space. And that location is 34? Yeah. 34,000 light years away. So now we've gone from the blue snowball, which was something like 3 or 4 or 5,000, to something that's far away as 34,000. In fact, if you click on the galaxy little icon at the lower right, it will show you where it is in our Milky Way. So on the right, you can see that this object, M15, Messier 15, is outside of what we call the plane or the disk of our Milky Way galaxy. The disk is where a lot of the young stars, the stars that are currently forming, and our sun, which is relatively young in the grand scheme of things, sits in the disk. And so we're looking out of the disk towards that globular cluster. And so in the field, if we go back to the field of view, most of what you're seeing there is the globular cluster, but there are other stars as well, and those stars are just part of our own Milky Way galaxy, so they're really close by, especially that big one that Richard is pointing to. So, like I said, there's about 500,000 stars, and the length, the size of this globular cluster is only about 100 light years across, I think. That's what I seem to remember. And
About 175, it says.
175 light years across. So to put that in perspective, around the solar neighborhood, if you go out 100 light years away and say, well, how many stars are there within 100 light years of the sun? There's only about 100. So these densities are a lot higher. These stars are really packed in tight compared to stars that you would have in our neighborhood where we are in the Milky Way galaxy.
It would make you really think about what your night sky would
It
look
would
like.
look, it depends on where you are. If you're in the center, you would not have a night sky, I don't think. I think it would be
Just all
uniformly
daytime.
bright all over the place. If you were on the edge of the globular cluster, and I actually did this once with a program called Space Engine, which is really cool. You can just go to a star in a globular cluster and see what it's like. You would have a night sky that was absolutely and completely black unless that rest of the globular cluster is in the sky, and then it would be very bright. The other thing about these guys, you may notice, it might not be exactly obvious because we haven't worked a lot with the colors, but the stars that you see, the brightest stars in this cluster, are typically very red. When you're here in person and looking through the eyepiece, you can actually see that some of these bright stars are red, and that's because these stars are red giants. These are stars that have run out of hydrogen in their cores, and now they're in the process of converting helium into heavier elements. And when that happens, for theoretical reasons, which I won't get into, the star puffs up and just becomes very large, and it cools off, and so it becomes red. But because it's become so large, it also becomes very bright, and so that's why these stars are particularly bright in this cluster. And these are probably also the oldest stars, some of the oldest stars we have in our Milky Way galaxy, because they probably formed when the galaxy itself was still in the process of formation. And so these stars can be 10 and 12 billion years old. That's
Yep. The telescope that we're using tonight, the 60-inch telescope at Mount Wilson, was used by an astronomer named Harlow Shapley to observe many of these globular clusters. And he basically created a three-dimensional map of the Milky Way for the first time ever back in 1917. using this telescope, which was the world's biggest telescope from its opening in 1908 until 1917. So this telescope that we're using tonight is the telescope that measured the size and shape of the Milky Way by looking at these globular clusters, as well as placing us in the galaxy by making that map with this telescope. Shapley figured out the Milky Way is about 100,000 light years across, give or take, and that we are nowhere near the middle. We're kind of in the not the outskirts, but we're getting into the suburbs.
If the center is downtown.
Yeah.
Yeah, I mean, that's one of the things I love about Mount Wilson. You have astronomy, like current day astronomy, but you also, I mean, this place is just steeped in the history, and these astronomers that I read about and their discoveries that I read about and I learned about all through my academic career, and to actually be using the exact same equipment that they were using is a little bit heady sometimes, not gonna lie.
So, if you heard the dulcet tones of our dome rotating, that's because Tom has moved the telescope back to, well, actually, this telescope was never pointing at the moon. but
Not
we have
earlier.
Moved, 60-inch has moved to the moon. Maybe we should move the refractor to the moon too. My mouse died. Your mouse died. Technical difficulties. It's very cold up here, and batteries are not working as well as they probably should.
And for all of our wired equipment, the wires are now super stiff.
Yeah. So we're going to move into position. And I think what we're going to try to do is point to the position that we think Mars should be, which will be behind the moon, and then we'll just let the moon drift away, and then we should see Mars rise, and then we can start tracking Mars and just follow it. That's the plan. Yeah, let's do the
Wow.
show that. You want to put it
No.
on the ATEM? What is it?
We are in ATEM, but I think he has to change monitors. So Richard is working with two monitors hooked up to his computer with the feeds from both telescopes coming into the computer.
Okay, so here, obviously, we're looking at the surface of the moon, very zoomed in, because again, excuse me, the 60-inch telescope is f/16. Is that the casting ring focus? Yes. Yeah. So, for those of you who do the astronomy as amateurs or professionals, for that matter, at the position that the camera is in, this telescope is an f/16, and that just gives you the ratio between the focal length and the diameter of the mirror. And it just means an f/16 with that diameter is you get a very small field of view for this chip. And that's because this telescope was built in 1908. There were no such things as CMOS cameras back then. In those days, you would use plates of glass that were covered in a photographic emulsion. And those typically were something like 4 inches by about 5 inches. So that's what this telescope was designed to use, whereas we are using a very small, in comparison, sensor. And so we're going to see a zoomed in view. Are we tracking sidereal or tracking
That's good. I see the lid.
Oh, you see the, oh yeah, okay, there we go.
Okay, good.
All right, so if all goes well, if the pointing is good, we should be on Mars. It's just that the moon's in the way. And so we're just waiting for the moon to move out of the way. And as you can see, the edge of the moon is coming in at the upper right. And so that gives you an idea of how fast we're moving and how long it's going to take. Now, when it first comes out, it may be dim because we've adjusted the exposure so that you can see the moon. Whereas when we look at Mars, we're going to have to turn the exposure up, and so the moon's probably going to become very bright, and you probably won't see those wonderful craters anymore.
But those craters on the moon, in fact, all craters, are made by impacting objects. These would be in the form of asteroids, large or small, depending on the size of the crater. A larger asteroid would make a larger crater. But these are basically impact scars. And if they're very large, like you can see the one on the far right-hand side, you can see the circle of the crater, but there is also the rock pretty much liquefies by the energy of the impact. And if you've ever seen slow motion drops something drops into water, how it kind of splashes up in a circle and then kind of rebounds in the center. So you can see a central peak, if you would, that would be the rebound of that rock after the impact. And this is only really something you see in very energetic, very large impacts. But we are looking at,
Are you trying to figure out which craters these are?
I'm wondering, it must be this, right?
Probably,
Maybe.
yeah.
yeah, maybe
you
that
tap
one down
here-
there,
That one, yeah.
a dark, yeah.
This is always a fun part. We have Sky Safari going here, and we're looking at the picture of the moon from an atlas, and we're trying to figure out which craters are which.
This crater on the right-hand side,
Yeah.
which one is it? This is our informational app,
Yeah.
Sky Safari, and we're like, could be that one, could be that one. Zoom in.
Trying to see if I can make this smaller.
We're gonna
It's
try-
pretty,
yeah.
it's pretty close to the limb.
Yeah, I think
So the limb is the edge. So maybe it's one of those?
because where's Mars gonna come out? That's the other thing.
I don't know.
Well, we're going to find out, I hope.
So one of the reasons, if Mars, we're kind of locked on Mars, but the moon seems to be shifting out of the way because as well as the Earth rotating, that gives us the apparent motion of all the stars and the moon and the planets east to west over the course of the evening, and the sun east to west over the course of the day, as well as that motion caused by the rotation of the Earth, we have an additional motion of the moon as the moon orbits the Earth. And then we also have Mars orbiting the sun, and there's just so many motions going on. So yes, computers are very helpful to keep track of all of those motions. Now, it says Deimos down there, which is one of the moons.
That's, maybe we're looking here, what do you think?
So you can see Deimos if we zoom in a little bit. Oops, not so much. Deimos is one of the moons of Mars.
All right, let's go back. I don't want to miss this.
So yeah, we gotta go back. We gotta go back. We can't miss this coming out.
So we are now 1 minute away from when it's
So
supposed to
exciting.
happen. But, again, this was, depends on where exactly we are and
You can hear a pin drop. Like we're all holding our breath.
Suspense is killing me.
We're trying to not block it and yet provide it. It's,
yeah. I don't
So
know.
two views.
Maybe on the other side? Like if you bring it all the way to the right? Yeah, there you go. Well,
Ah!
I did not like that.
Okay.
Well, actually, you can have both if you do it that way.
And you need a magnifying glass to look in.
Yeah, that's what I thought. So let's go ahead and leave that like
So
that.
this is the,
Full screen, come on.
okay.
there we go.
We were going to try and
Let's
show
see.
both the refractor and
Well,
the.
it says Mars is coming.
It's supposed to be coming.
It's supposed to.
Almost there.
Richard, get rid of that. Put it.
Well, in that case, I'll see it first. Because I'll see it right there.
Oh, we might need to bring exposure up on the right-hand side. Yeah, on there. 'Cause we're currently set
Well,
for.
it's supposed to, it says it's coming out.
Oh, there it is.
There it is.
There it is.
Yay! Hello, Mars. Well done, Richard.
And we're actually
And Tom for
Tom
pointing
pointed
the
it.
telescope. That's
we're
right.
actually getting color and some
Oh, we are. We're seeing features. And this is why the 60-inch telescope, this is why a larger diameter telescope is so much better than smaller diameter. You can collect more light. You can collect enough light to give a color image, and you can see, your resolution is better, so you see more details. And what you're actually looking at is the surface coloration of Mars itself. We're looking right through Martian atmosphere to see the surface of Mars.
So do we want to zoom in a little?
Yeah.
Sure. Now that we've actually seen it happen.
No, I actually see features.
Okay, so we did a test on Monday night, and we could not see any of the details. Is that the polar cap at the bottom?
Yes.
Okay, so you can see the polar ice caps on the
Polar
bottom.
ice cap.
And who's going to be first to figure out which Martian feature this actually is? I should have thought about this. I didn't think to look at the atlas.
We didn't think we'd get this lucky.
Yeah, all right.
Yeah, we
exactly.
didn't, yeah.
I don't know if Sky Safari tells you what the features are. Oh, and what Richard just brought up, that's our handy little thing that lets us play with the focus without actually having to send somebody up to the eyepiece and mess around with it.
It's looking really good tonight.
Wow,
It is
beautiful.
surprisingly good. Like,
I mean, and for our audience out there in internet land, if you're used to seeing Hubble Space Telescope images and now James Webb Space Telescope images,
This is what they get too. They just fix them afterwards.
yeah, they often have images that do need color correction and whatnot. But this is a ground-based telescope, and we have 100 kilometers of atmosphere and shifting air mass that we have to look through. This is remarkable. Wow. There are 2 moons
Yes.
of Mars, Phobos and Deimos. Deimos apparently is up and to the right of Mars itself.
It's going to be very, well, we can try to.
Now,
Gain like crazy.
oi oi, we need to get the moon out of the out of the field of view. So both Deimos and Phobos are less than 20 kilometers in diameter, I believe.
Yeah, it's not.
That's, yeah, they're tiny.
They're teeny tiny.
See, so we're not getting those.
Yeah, if we go over here, you can see,
oh, they're that far away.
yeah.
Okay.
So what's the,
I was trying to see it's 12.8, is Deimos is 13th magnitude, and
it's
it's
15 by 12 by 11 kilometers in size.
Yeah.
Yeah. Okay.
what's the limiting magnitude? Well, wait, we're using cameras.
We're using a camera, so it's probably the back. It's probably the background from
Welcome
the moon is
from
probably drowning it
Wales.
out. We'll probably drown it out.
Goodness, what time is it in Wales now? Someone got up very early to see the moon and Mars. Maybe they're up walking their dog, but
I don't know. I can't do that time zone shift in my head.
is it 8 or 9 hours ahead? 8 hours ahead?
What'd you say, Jeff? Yeah.
Wales.
All right, it's GMT, of course.
Yeah. So that's too early to be up walking your dog. Whew.
My hands are so cold they don't want to cooperate.
Poor Richard, his hands are so cold that, yeah, for those of you who didn't hear his comment, his hands are so cold they're not pressing the right buttons on the mouse to get to the right.
Nowadays,
That is good.
Yeah, but it needs to be brighter.
No, it's looking great. Wow. Okay, how does it look on YouTube?
I mean, probably pretty good. I'll go look.
Wow,
Yeah, go have a
the
look.
detail. 3:45 a.m. He's confirming.
Well, thank you.
Thank you for joining us.
That's dedication. That's well, okay. It's doing well from our laptop here, and Jeff can tell us if it's doing well on YouTube. That's pretty good. I'd say that's fantastic.
And normally we don't do our observing in the dome. When you have a computer and a camera and you can do your take your digital images from anywhere, we prefer to be in an air-conditioned, climate-controlled room in front of a computer. But it is really fun being in the dome. It's just very cold tonight.
Very cold.
Yeah, I'm beginning to lose sensation in my toes. We can see our breath in here. It's good times.
Yeah.
Oh, Mars is beautiful.
But it is really fun to be at the telescope. I don't want to knock it.
And you know, if you were here and using your eyes at the eyepiece, this is approximately what you'd see. In fact, I suspect it would probably look brighter than that. And you might actually have to put a filter in front of your eye because Mars would be so bright that it would be hard to see these features. And sometimes we let people put their sunglasses on, or we have special filters.
What are we?
Oh, it's warmed up a little bit.
Down there, yeah.
Okay.
Yeah, one
30
thing, yeah, sorry, go ahead.
31.5 degrees Fahrenheit, so
It's
just
officially below zero, just
like
below zero.
minus 0.2 Celsius. Oh. Yeah, it's gonna be chilly in Wales as well. He had a frosty back garden.
We have to keep adjusting focus because as everything cools down, it starts to, all this metals tries to shrink.
Right.
Yeah.
Okay, so Sky Safari's view is I guess flipped upside down.
Can you see Mars with the naked eye again yet? Is it far enough away? It's still too close.
Oh, why don't we go back to your refractor so we can see the wider view?
Yeah. And for those of you who are actually looking from a position in Southern California, the reflected sunlight from the moon may be so bright and kind of flooding your eye with a lot of light that you cannot see the very faint dot that is Mars.
Oh, we could show the demonstration of why this is happening
Okay.
with the Sky Safari.
Oh, right. The Sky Safari. Okay. I was about to say, do we have demos in here? But the digital demo.
Oh, that's true. We do that too. All right, so
Let's bring the microphone over here. Oh, so many wires. There's the mouse. Let's move this computer. This mug. Okay.
I don't think so.
So we're getting over here. There you go.
Okay, so this is currently Sky Safari. So I'm going to zoom out a bit. And that just shows you where it is, relative to the horizon up here at Mount Wilson. But what Sky Safari allows you to do is if we go to choose the sun, and I can orbit the sun. So that takes us off the Earth and puts us into the solar system. And I'm going to zoom in so that we're looking at the inner planets. Oh, maybe zoom out a little bit more so you can see where Mars is. There we go. So I'm going to go back in time several days and just do it in fast forward, just so you can see how the motions go. So this is going backwards in time. Okay, going forwards in time. What you're going to see is that Earth is catching up with Mars. It's on an inner orbit, so it orbits around the sun more quickly than Mars does.
Can you slow it down a bit?
Not easy. I can do it. Not really. It's unfortunate.
Fair.
There, and then we pass Mars, so you can see where opposition happens when we are between. I'll just do now. When we are between Mars and the sun, that is what we call opposition. Now I'm going to turn this around.
So basically you draw a line from the sun through the Earth, and then that straight line hits Mars.
Yeah, so everything's nicely lined up like that. Now we're going to go back in time, but now I'm just going to step by hours. Now I can let it go for a little while. Okay, see how things are going. Oops, shoot, wrong. Okay, and now I'm going to put myself on the Earth. Oh, this screen is so cold. And then I got to touch and hold, and then I can orbit the Earth instead. So now we're going to head over to the Earth. There we go. And now you can see where the moon is. So I'm going to zoom out a little bit because it's a little bit too far.
Can you turn the orbital paths of the planets off?
I can't. I don't know how.
Okay,
But
that's
anyway,
fine.
so now this is tonight, but this is like at 4 a.m. So if I skip ahead an hour, you can see that the moon is coming in, but it's coming in towards the left.
We can see the Earth rotating there as well.
Oh, that's nice.
And it's moving along its orbit around
Right.
the sun.
And that is a nice timing for us here in California because the Earth turned in such a way that we are on the other side, away from the sun. So it's nighttime for us, but not too late. And now let's go forward by
Africa
minutes.
doesn't get this view.
All right, and here we're going forward in time by minutes. And now you can see what's happening is that the moon is now coming in from the left. Sorry, in from the right to the left.
And kind of that's the view that we'd get.
Boom. There we go. And that's when we have the occultation, and then it comes out.
The moon
other side.
passes. It continues moving along its
Right.
orbital path.
Now, you might ask yourselves, why doesn't this happen all the time? Why does this happen every time the Earth catches up with Mars or in the moon and they're all in the right place. Well, if we put everything on edge, you can see those lines. Those lines are the orbits of the planets and the moon, and they're not perfectly straight. They're not all lined up. So if we come back to the next time that this happens, I don't know if I can do that. Let's see. You can see how much the moon kind of wobbles around the sky. And so it has to be in just the right place in its orbit so that everything lines up really nicely, like it did tonight. That.
There we go. Now, back to Mars.
Still there.
Still there. Still exciting.
And I just want to say welcome to everyone who's joining us from Glendale Community College. That is the college that I have the privilege of being a faculty member at. So my name is Professor Jenny Krestov. I am one of the astronomy and physics faculty members at Glendale Community College. And for those of you who didn't join us at the beginning, I am joined this evening with two astronomers from the Carnegie Observatories in Pasadena, California. They are Jeff Rich, sorry, I get that wrong every time. Dr. Jeff Rich and Dr. Christopher Burns. We also are joined by Mr. Richard Bell and Mr. Tom Meneghini, who are astronomers up here at Mount Wilson. So Richard is the telescope coordinator, and Tom is actually the executive director here up at Mount Wilson Observatories. And we have done live streams in the past. This is our friendly band of 5 astronomers who regularly freeze to bring you the universe as seen through the 60-inch telescope. But right now, we're seeing the closer parts of the universe. So not such distant places, but we are showing Mars. And Mars is merely 82 million kilometers from us at this point in time. This is a wonderful view of Mars. You can see some of the coloration. So the darker, kind of from the top to the center left of Mars, that darker coloration is actually hematite mineral or hematite. And the orangey, that is iron oxide. So the orangey coloration, iron oxide on Earth, we call rust. And if you look at it, you're thinking, yeah, it's kind of a rusty color. It does make me wonder, every time I look at Mars, it does make me wonder how the ancient Romans and Greeks called this planet after the god of war, because they thought this was blood red. I don't know about you, but the last time I saw blood, it wasn't rust colored. But, reddish, yeah, absolutely.
All right.
Anyway.
So I think at this point we're going to be putting the telescope away. What?
You can actually see it here if you look, visually, and it looks red.
Yeah, it actually does look red when you look at it, but from it's a bright background. So we are going to.
Are we wrapping this up?
We're wrapping this up. What we're going to do is we're going to put the telescope away, and we're just going to leave the wide field open so you can watch us put the telescope away. You can keep on asking questions if you like. We'll keep monitoring the chat, but it is cold, and we're ready to go home.
We are ready to pack it in for the evening. So thank you very much for those of you who have stayed with us since the beginning of the live stream. If you joined us a little later for the reappearance of Mars and the view of Mars right now through our 60-inch telescope, thank you so much. This is a view of the moon and Mars through a smaller 5-inch refracting telescope. If you are in Southern California, I don't know how cloudy it is down in the LA basin, but we can go back to the tower cam and have a look.
Looking pretty clear.
I don't know, there's clouds, that's to the north though. So yeah, it's looking pretty clear. So if you head out now, I mean, it's not super late, it's not even 8 o'clock in the evening, but if you head out now, you can have a look and see if you can see for yourself Mars and the moon. They should be pretty easy to spot because the moon is going to be the brightest object up in the sky, and Mars also pretty bright and not far from the moon.
Yep.
Anyway, I'm going to send it over to the view of the telescope and how it is moving, and then kind of the wide angle view of everything.
And you can just and of course, even though this is over, the same link should take you back if you want to watch it again to the recording, which will be left on.
So we're going to sign off now as you watch the telescope move. Thank you very much for joining us, and good night. Or good morning, depending on where you are.